Mike would.
I've done that a few times. All right, ladies and gentlemen. So, okay, today overall is going to be fairly quick. It's just talking about some of these new definitions that we have here. And we're going to talk about how to design an experiment. And then what you guys did with texting everybody was to get data so that we can actually construct an experiment. All right. So purpose of an experiment is to investigate the relationship normally between two variables. All right. It can be more than that. And it kind of depends on what you want to do. If you only have two variables, though, the explanatory variable is when one variable causes change in another. Okay. So, for example, if we talked about number of people going to the game tonight, for example, there are lots of different variables that could fall into that. Okay. It could, for some people, it could depend on weather. For some people, it could depend on distance and so on. Okay, so you could get a lot of different information based on lots of different games here. All right, the response variable is just what is affected. Okay, so for this one, the response variable would be how many people go to the game. The explanatory variable would be say that we would have a storm tonight. We're not supposed to, but say that we did. Okay, the percent chance of us getting a storm would cause the other variable to change. So that would be the explanatory variable. All right, and then as it says down before, the treatment is the different values of the explanatory variable. So say there was a 60% chance of having a storm tonight. That would be your treatment. Say it was a 20% chance. That would be your treatment, and so on. All right, and then lurking variables are additional variables that can cloud a study. Okay, so for you guys, say we were talking about that game, say that people have to work, say that people have, there's a big test tomorrow and you have to study for it, and you decide that instead. Okay, those additional things that might not be right on the top of the surface might kind of cloud a study in some way, and that's what a lurking variable is. All right, so I think if I remember right, those are our main definitions here. All right, so when in a study and a participant prompts a physical response, okay, so say for example, say there are people that did this for the COVID vaccine. They went in, they were part of a study to see if this COVID vaccine would work or not. Okay, there would be a physical response to this being taken. Sometimes it is very difficult to isolate the effects on the explanatory variable. Meaning, if you get a shot, sometimes it's hard to tell whether the shot actually worked or whether you think it worked. Okay, so to deal with that, what they do is, in a really good study, they will break all of the participants into two groups. All right, one will be given the full experiment. So one would be given the vaccine. All right, and then the other one would be called the control group, and then they control that group in some way. Most of the time, they're given a placebo treatment, which just means they're given something that's not going to do anything to them. All right, very similar to what they do with actual pill drugs is for one group, they'll actually give the drug, and the other one, they'll give like a sugar pill or whatever it's called. I don't remember what it's called, but that placebo isn't going to do anything. All right, but then what they'll do is they will ask the participants, you know, how do they feel after they take it? Okay, the people that took the drug, they will have certain ways that they feel. The people that took the placebo shouldn't have any effects, but sometimes they'll think they had certain effects. Okay, so say for example that they were testing out aspirin, for example. Okay, and at the time when they were testing out aspirin, everybody in the study had a headache, for example. All right, people that took the aspirin, hopefully the aspirin helped the headache. Okay, the people that took the placebo, okay, what should happen is nothing. Nothing should affect it. But when our brain kind of gets in the way sometimes we can go, all right, yeah, I actually feel better. So, and that is just kind of the placebo effect inside of us. We took something to help us feel better, so we think that that actually happened. All right, so that's normally what happens in a really good study. You get split up into two groups. All right, and one is given whatever the experiment is, and one's given kind of a fake experiment. Okay, and you compare the results from there. All right, so here's an example of one. Go ahead and read through this here. You don't have to write it down. I know there's a lot there. All right, so our investigation here is whether taking aspirin helps reduce the risk of a heart attack or not. Okay, we have 400 men between the ages of 50 and 84. All right, those men are divided into two groups. One will take aspirin, the other will take a placebo. Each man takes one pill each day for 3 days. But he doesn't know whether he's taking the aspirin or the placebo. At the end of the study, researchers count the men in each group who have had heart attacks. All right, so we can come up with, for each one of these terms, we can come up with the group that would fall in there. Population for this study would be what? What did you have to be included in this study? Right, you had to be a man between 50 and 84. Now, from there, there's your population. From there, we narrowed down the sample. What is the sample for this one? Yep, the 400 men. All right, now the experimental units. This is, who was the experiment designed for? No. Who was the experiment put on? Let's put it that way. The men in the study, right? Yes, ma'am. No, because it's already in the population, that's assumed. Okay, so what Abigail said was, for our sample, do we have to say 400 men between 50 and 84? That's already assumed because it's in our population there. All right, the explanation variable, what is changing in this study here? What is being given that's different between the two groups? The aspirin or the placebo, right? Placebo. All right. What is the treatment? Yeah, this one is the exact same thing. The explanatory variable and the treatment happen to be the same thing here. Okay, part of the group is going to get aspirin, and part of the group is going to get a placebo. And then the response variable, what kind of response are we looking for here? Yeah, this happens to do with the heart attacks. So whether the man had a heart attack or not. All right, so now there are people that their job is to do this. They design a study and they're waiting to see whether a guy has a heart attack or not. But, huh? Well, yeah, but so I don't. Right, right. So is this the best study in the world? Not really, because you can't necessarily predict something like that, okay? But the one thing is that does help with this is done over a 3-year period, okay? Normally, the older you get, the better chance that you have for a heart attack. So when you have a longer study for this, the more likelihood you're going to get better results from it, okay? But yes, Ethan, you're right. This is kind of a weird one just because nothing's guaranteed there. Okay. All right. Plus, there's more involved in this than just taking aspirin or not, right? Yep. Right. Age counts. Okay. Your health counts. Yeah. Different risks that you already have count. So there's got to be, to actually do this in the real world, you got to have a little bit more specific example going on here. All right, but this would be an approximation of what we're doing here. All right, so take a look at this one. We have a researcher that wants to study the effects on birth order on personality. Explain why this study could not be conducted as a randomized experiment. Why is it going to be hard to conduct this as completely random? Right? Okay. Do you have any control over somebody's order in how they were born? No. So that's why this cannot be a randomized experiment. What is the main problem in a study that cannot be designed as a randomized experiment? What do you think? What is a main problem in a study that can't be designed as a randomized experiment? Right. Yeah. So then because of that, there's bias thrown in there. All right. So, I mean, think about you guys with birth order here. Okay. All right. Say that I want to do this. Well, we've got all sorts of different birth orders in this class, right? Okay. We have lots of oldest kids. We have a handful of youngest kids. All right. But it is definitely not randomized in here. Okay, so there's going to be issues with that. Okay, and when there's issues with that, then our statistics can kind of get a little messed up, kind of like what we're going to talk about here. All right, when you are talking about statistics, all right, it is very important to be able to, first of all, as we are reading statistics, we have to figure out what the heck they mean. Okay. One thing that is very true is, yeah, numbers don't lie. All right. But we have to figure out what those numbers mean. Okay. What we have up there, what I have up there on the board is a list of running backs in the NFL in order of the most rushing yards in NFL history. Okay. Now, if the question was, look at this list of NFL running backs and tell me who the best running back in NFL history is.
This is one on the bottom.
You think so?
Yeah, that's what I said.
All right, Maxwell, what are you thinking? Why? Does he still? I think he does still. Okay. So, all right. So you're saying that. Okay. Who else has an opinion? Why, Eli? Okay. That plays in, doesn't it? Okay. And notice this. I did not put how long they played up there, right? We just put total yards there. Okay. So what Max said is right. What Eli said is right. Okay. Other variables that could be thrown in here is what kind of team did Emmitt Smith play on for the most part? He played on a really, really good team who he ran behind, who most consider one of the best offensive lines in NFL history. Is it a little bit easier, Eli, as a running back? Is it a little bit easier to run behind really good offensive linemen or really bad offensive linemen? You were going to go there, Ethan, huh? Oh, that's true. He did. All right. So, hey, guys. So what we're saying here is if you just look at one statistic, is there any way to truly tell? Not necessarily. Okay. For some people, okay, I never saw him run, but for a lot of people out there, they consider Jim Brown as the best NFL running back in history. Okay. Now, reason for that is he played a lot less than anybody else on this list, and the seasons were a lot shorter back then. Okay. I'm old enough to say that I've seen everybody else on this list, which is kind of sad, but and I'm a Bears fan, so I would say number 2 is the best, but that's just me. I would not argue against Barry Sanders. Okay. This one is very interesting because Frank Gore, to be number 3 on any list, I don't care who you are, to be number 3 on any list means you had to be kind of sort of good. Okay. He, if nothing else, for him, you could say he was good enough to be on a team to actually get the ball for, I think he's pushing like 18 years or 16 years or something like that. It's ridiculous how long he has played. All right. He is, I don't know if he's ever for any one year even been in the top 5 for a year. But when you are consistently out there doing what you're doing, that has to hold up for something there. It has to mean something. And that's a very interesting one. All the rest of them, you could say they all had points where they were really, really, really good. All right. To say which one's the best, is there truly any way to know? No, there's too many variables involved. Yes, ma'am. That's okay. Okay.
So like for me, I just say like number 1.
Right. And that's what most people would do. Most people default to that because they're on top of the list. Okay. And that's okay. But that's where, while numbers don't lie, they can lie. All right. So when you come up with a study, if you were to do that, you have got to make the numbers mean something. All right. So last one here. All right. So what we need to do is we need to come up with the unethical behavior in each one of these examples and describe how it could impact the reliability of the data. All right. So the first one, she selects a block where she is comfortable walking because she knows many of the people living on the street. Are there issues with the data that she's going to get? Yeah, what would those issues be? Yeah, she knows everybody. So there's bias already built in, isn't there? Okay. All right. Even if she doesn't know everybody there, do a lot of the people in the same neighborhood probably have similar beliefs, have similar things that are important to them. Yeah. Okay. All right. We see that many times financially. All right. So depending on where she lives, yeah, she probably has a lot of people that think very similarly to her in that area, depending on the situation. All situations are different, but that can definitely throw a lot of bias into that situation. For the second one, no one seems to be home at 4 houses on her route. She does not record the addresses and does not return at a later time to try and find residents at that home or at those homes. Is there anything wrong with that? Okay. So what Caitlin said is correct. If you're not going to get an answer, you should at least put that down. Put that into your data. Okay. No response. All right. That's okay. If you put no response into there, that's okay. And then there's not an issue at all. If you just throw them out because you weren't able to talk to them, then there's some sort of bias thrown into there too. Okay. All right. And who knows what the reason is? Maybe they're working 3 jobs. Okay. Maybe they're on vacation. You know, whatever the reason is, okay, you at least have to record them in the data. Okay. The last one down there, she skips 4 houses on her route because she is running late for an appointment. When she gets home, she fills in the forms by selecting random answers from other residents in the neighborhood. Is there an issue with that one? Yeah, what's the issue? Yeah, she's putting in answers for people, whether she talked to them or not. That's going to be an issue. There is bias thrown in there. And because of that, is her study going to be, no, it's not going to be an acceptable study. Okay? Any questions? All right, so here's what I need. Hopefully this is going to work. That was 1.4. Going on to 1.5. What we need is you need to grab, what? You need to grab your phone, okay? And you need to record on your sheet of paper the first 5 responses that you got, okay? Hopefully by now you have 5 responses. No, you don't have to put their names. We just need numbers. I would probably say that too, but all right. So do me a favor, just write down your first 5 responses. No, just write them down. Yeah, I'll explain as we go here. You couldn't even text your mom there, Eli. Well, then text your dad. Don't we know better than that? It happens. All we need is numbers. Yep. Nope, just the first 5.
I only got 5.
That's okay.
Every day. Every weekend, both days. When I first got to you, I always really